6.1 example 4 says write an inequality to represent the graph. So before we were given the inequalities and we were asked to graph them. Now we're doing the opposite. We're provided a graph and we want to come up with the inequality that would have given us this graph. So the first thing we want to do is try to identify what's our slope, what's our y-intercept, so we can get it into the y equals mx plus b form. And then identify what our inequality is based on which side of the line was shaded. Is it a solid line, so I'll have an equals with it, or is it dotted, so it'll only be greater than or less than. So in this form, y equals mx plus b, let's identify our slope. So let's pick 2 points. I'm looking here and here. It's a positive slope. I'm going up, right to left. I'm going up 2 and over 4. So my rise is 2 over 4, which can be simplified to 1/2 x, and my b is my y-intercept. Where did I cross my y? Was at 2, so plus 2. So my equation is 1 over 2x plus 2, but I know it's an inequality, it's not an equation, so I need to get rid of my equal sign, and I determine, is it a less than, greater than, less than or equal to, or greater than or equal to. So I shaded below the line, which means less than. We had written in our notes before, y is less than x if I shade below my line. So I know it's going to be a less than. Is it going to also be an equals to? Yes, because my line is solid. So I know that I will have y is less than or equal to 1/2 x plus 2 based on that graph. If you're ever unsure, you can pick a point in the shaded area like 0 and 0 and test to see if that satisfies. So for instance, 0 is 0 less than or equal to 1/2 times 0, which is 0, plus 2. So is 0 less than or equal to 2? Yes. So that satisfies and our inequality works. Part B, again, we want our slope intercept form. So our boundary line has a slope of 0 if it's horizontal. So I know that my slope is 0. So I won't have an m here, which means I also won't have an x because a slope times x is 0. Our y-intercept is right here at 1. So it's at 1. And how I would write that out would be like this. Again, 0 times anything right here is 0. So I can just write y equals 1. That's my line. But again, I have an inequality, so I need to double check that sign. It can't be an equals. So it's above my line. If I shade above, that means my y values are going to be greater than my x values. And it's a solid line. So y is greater than or equal to 1. And part C, we have a dotted line I can see, is a negative slope, and I'm shading underneath that line. So I know I'll have a less than, and there won't be an equal to. We just need to figure out what that equation would be. So I have a negative slope, and if I pick 2 points that it's going through exactly, say right here and here, I'm going down 2 and over 1. So my slope is negative 2 over 1. It intersects my y-axis at negative 3. So written out would be y equals negative 2x minus 3. Now, to get rid of our equal sign, what inequality are we going to put in there? We shaded underneath our line, so that's y is less than x if it's underneath the line. And it's dotted, so there's no equal sign. So y is less than negative 2x minus 3 is the inequality that goes with our graph. Again, let's test 0 and see if that works. See that we actually shaded the right thing and came up with the right equation. If I test 0, is 0 less than negative 2 times 0? So 0 minus 3. Is 0 less than negative 3? No. So we know that it's shaded properly because our test point is not in the shaded satisfied region. Example 5. Ben is buying snacks for his friends. He has $10. The choices are apples for 80 cents and muffins for $1.25. We need to write an inequality in 2 variables to model this situation, and we need to define our variables first, which means let statements. So we need let x be, and we can determine is that apples or muffins. Let's just say number of apples. It's really up to you. And let y be the number of muffins. If we cannot buy anything worth more than $10, we know we're limited to that. We can pay for this food and equal exactly $10 because we have $10, but Ben can't pay more than that. So right now I know there's a less than or equal to. It's 80 cents per apple plus $1.25 per muffin, which will be less than or equal to $10. So 80 cents times the number of apples that I buy plus $1.25 times the number of muffins that I buy has to be less than or equal to 10 because Ben, not me, Ben only has $10. Part B says state the restrictions on the variables. So what does that mean? Are there any limits on the amount of number of apples we can have or number of muffins that we can have? We can only have whole numbers because we can't buy negative amounts of muffins and we can't buy half a muffin or half an apple. So we need to have X as an element of our W, which is whole numbers, and Y as an element of W. And if you're not sure, you can leave yourself a note that whole numbers, we use the symbol W. So whole numbers is 0, 1, 2, 3, and up. So no negatives, no fractions, no decimals. So to graph this function, I'll rewrite it again. We have 80 cents for an apple plus $1.25 per muffin has to be less than or equal to $10. We want to solve for our X and Y intercepts so we can find out how many apples would I have if I buy 0 muffins? How many muffins could I buy if I buy 0 apples? So our X-intercept is where we cross the X-axis, and that means our Y value is 0 there. So we want to plug that in. 0.8 X plus 1.25 times 0 is less than or equal to 10. So we know this will cancel. Anything times 0 is a 0, so we don't have to write that again. And we need to solve for X. So we need to divide both sides by 0.8. X is less than or equal to, notice how I didn't change my inequality because I didn't divide by a negative. X equals 12.5. So when we have an equation, actually, we can just have our equal signs instead of our inequalities. So 10, I'll just rewrite that. How we graph it is with an inequality, but when we're actually solving, we'll have an amount. I won't have less than, I will have 12.5 apples if I buy 0 muffins. Now I want to find my y-intercept, so that's when our x value is 0. So we'll plug in 0.8 times 0 plus 1.25 y equals 10. Again, anything times 0 is gone. 1.25 times y equals 10. We're solving for y, so divide by 1.25 so that those cancel. Y equals 8. So these are our intercepts. So let's plot those points. This intercept, my x is 12.5, not 1.25. 12.5 when my y is 0. So at that point on our graph, we want to have 12.5 as our x-intercept. So let's go up by, let's say, 3s. 3, 6, 9, 12.5 in a bit. And we'll go up by 2s. 2, 4, 6, 8, and 0. X is 0, y value is 8. Now it's less than or equal to, so I can have a solid line connecting these points. But because I have a domain restriction, I'm only looking at this first quadrant here. Everything has to be positive. My x values have to be positive and my y, so I'm actually stopping at those points. And because we said it's only whole numbers, we want to stipple inside. We want to put those dots on all the values that would exist. just like that. And last part, D says, why is 5 and 4.8 not a solution? Well, keep in mind what we said our variables were. X is the number of apples, so I have 5 apples, and Y was the number of muffins. 5 and 4.8 is not a solution because you cannot buy 4.8 muffins. And 4.8 is not a whole number. Which we said our restriction was on our domain. So your assignment is below. Page 303, number 2, 5, 6, ACE, 7, 8, and 10 to 12. Please let me know if you have any questions.